Good morning. I'll be talking today about lead zirconate titanate, also known as PZT. This picture here shows the actual composites that were made. They start out at the base wider, and it said it was around 110 microns. And then by the time they started making the main portion of the 3D printed part, it became 90 microns. The paper was called 3D Fine-Scale Ceramic Components Formed by Inkjet Prototyping Process. It was done in 2005 in the Journal of European Ceramic Society, completed in France. And the main scope was to look at how adjusting the fluid properties and controlling the ejection and impact phenomena changed the outcome of printing, and if they could create high definition parts. So here's the matrix of what they created. Each one of these is the PCT rods. We look at viscosity and then the ejection velocity for the two studies. Don't really know what they used to print these. It just said that the company SPTCS, I think, SPCTS laboratory made adjustments to some object or some 3D printing machine to reach their desired definition, which was looking at trying to get it to be able to create high definition parts at a 10 micron I guess definition in the XY plane and 1 micron definition in the Z plane. And then to perform their studies, they used a CCD camera setting to look at the inkjet printing and what was actually dropped from the head, and then used a SEM and laser interferometer. So this is the study of the viscosity, how they could change the fluid properties to create the desired droplet. And the first one right here was if the properties were too low, it caused great increase in viscous forces and caused large ejection pressures, which causes not a lot to come out based off of their printed pressure. But if you went too high, then you got this droplet with a column that formed behind it, and then that led to beads being formed behind the droplet. But if you got the average or the adequate range between 1 and 10, then you could get one exact droplet here. And this is a ratio of the Reynolds number over the square root of the Weber's number. And so for the study, they were looking at about 6 as the ratio that they got here. And then they wanted to see the effects of the velocity of the droplets coming out of the printer head and how that affected what was being seen I guess the topographical view of each drop. And that's what we see here is the 3D topographical view of it, which was done by the CCD camera. And then they also varied the voltage at which these droplets were ejected at. They used 2 different ones, mainly. I guess they showed over the range, but they mostly talked about the difference between the 65 and the 79, and how the velocity changes and the volume changes. And down here, this was a part, or the velocity being at 3.4 meters per second, which showed the 3D image. But down here was the SEM view of a 1.5 and a 2.9 meters per second droplet speed, and the droplet becomes more uniform as you get to higher velocities, which can be seen in this graph here as the red line is the 2.9 is closer to being the same throughout the whole part, compared to the 1.5, which you see high peak and then a low peak as it goes back up to high peak too. And this is from the outer edge going into the inner diameter, the center of the droplet. And as you can see in these two graphs, or these two pictures here, there is less differentiation between the colors, which shows that it is more uniform. Yeah. And then, so in summary, the optimal ratio for viscosity, which is, again, the Reynolds number over the square root of the Weber's number, is between 1 and 10. And this, by achieving this, you'll create droplets in the optimal range, and it'll be a single drop instead of being either too small or creating a column of beads. And then the higher the voltage produces a higher volume, which we can see here. The higher the voltage increases, volume also increases, and so does velocity. And then higher velocities produce uniform drops. The paper was very straightforward. It's pretty short. There was 4 sections, and it wasn't like a typical paper that I was used to reading, where it kind of gives the setup and then what they changed and what the results were, and then conclusion.